Well, I've got three things to say on that. I mean, firstly, automation doesn't need to be a dirty word. There's still a role for automation as a foundation for autonomous networks. Secondly, I mean, everybody this year is talking about agentic AI. Last year, they were talking about generative AI. And we should be careful not to forget machine learning because that still has a really big role to play. As an example, making predictions about traffic patterns or helping us spot an anomaly in the network. Finally, AI isn't new to Nokia. We've embedded it across our whole portfolio. Once again, I've got three things to say here. First of all, this isn't just about technology. It's about people and process. I've got a great example of a AI solution that we developed back in 2016, and it failed. And it didn't fail because the technology itself was wrong. The model itself was 92% accurate, but for various reasons, people either weren't able to implement the recommendations of the model or they didn't want to. They didn't trust the system. That pretty much leads on, I think, to the second part, which is AI needs to be explainable. We need to understand what data it's using. We need to understand how it's making a recommendation. And finally, we need to know if we can trust it. So how accurate is it? Then the third part then comes down to a very basic thing, which is you have to have quality data and you have to have quality data at scale. One example I can give you, a very big operator in the US, we actually built a data platform for them, and it's able to ingest data from multi-vendor network across radio core transport domains, and it can handle more than 270,000 reports a second. So you need to have that scale, but more importantly, you need to have quality data that you can trust as a foundation to feed into an AI model. Nokia launched its autonomous network fabric. That's part of our vision to create networks that can sense, think, and act. And if I explain a little bit about each of those three steps, the sensing part is about having a unified data management solution that delivers quality data. The think part, it's about having explainable AI, as we said earlier on, and that's a mixture of machine learning, large language models, large action models. And then finally, on the act side, we already have things like closed loop automation, but now we have agentic AI to actually implement the recommendations that we're getting from AI systems. And, what could such a system do? Actually, we don't need to dream too big. We could just think of the ability to predict an hour in advance that there's going to be a problem in the network or there's going to be an increase in traffic and some congestion. That's enough for us to take some actions to preempt that, to avoid that. And that's going to avoid customer complaints, churn. That's going to avoid unnecessary truck rolls. And all of that is going to have a direct impact on OPEX, so driving down OPEX and improving the customer experience. It's a difficult task. I would say that, job one is always security. That's foundational. That comes into effect with things like design for security, making sure you've got endpoint detection and response on the network functions, that you've got a security orchestration system as well. And ultimately, these two things don't need to be contradictory. I mean, AI can actually help us to provide a network that's more reliable. There's a great example. Nokia's been looking at essentially like a network on demand concept. And what you can do is you can create a mini network in the public cloud. So all of your core network functions, so packet core, voice, registers, etc., dimension that with just to handle a small amount of traffic. In the event that you need more capacity, you can move traffic over to the public cloud. And in a lab trial, we've been able to move traffic for 10 million subscribers into the public cloud in about 10 minutes. So that kind of shows you the role that AI can play. Well, everybody's talking about agentic AI. I think it's worthwhile looking at something that's a little bit more pragmatic. Digital twins, right? We've been talking about those for a few years. They're used extensively in lots of other industries. And they're used in telecoms, but so far, most people are talking about things like a digital twin for the radio access network. That's great. It can allow you to do some things. We think there's a really good possibility to apply digital twins to the service layer and the end-to-end service layer. So you could use that to design your network, to implement a new service, to run simulations, to run test cases, and even to actually improve your troubleshooting and resolution of issues, because you can simulate that in a safe way in a digital environment, learn the lessons, and then apply that into a real world scenario.